In this problem, we have a repeated root. We have a perfect square, x plus 2 quantity squared. And so to integrate this term, you could think about maybe breaking it up as this over that, this like this, and then having common denominator. But the problem is you still have this repeated root. So this is in a situation where partial fractions can be very helpful in breaking this apart. So I'm going to ignore the integral for a second and just focus in on the uh, writing out the partial fractions. So I'm going to write it as x plus 2 squared. And so when you have a repeated root like this, what you need to do is consider the case of a single root, but then also take into account the fact that that root may be repeated. Okay, so for every term that you have, you're going to multiply. So if this was a cube, then you would have an x plus 2 squared and then a plus c x plus 2 quantity cubed. So for each of the repeated roots, we're going to get an extra factor to consider. Okay, then the process is exactly the same from here on out. The setup is really just being sure you have the right to account for to keep each side equal. Okay. So you're going to multiply everything through by x plus 2 quantity squared. So that's going to leave this left-hand side as 6x plus 7. That term cancels out. Here, since there's only one root here, you're going to have an a x plus 2 left over from here and a single b term there. Okay? So in this situation, since we have linear factors, the first thing I'm going to do is let x equal whatever number will make this term 0. In that case, x would be equal to -2. And if I can solve that, then the other term, I can choose another value for x and get what b is equal to. So x minus x equals -2 means that I have 6 times -2 plus 7 equals, now this term is 0, so I'm left only in terms of b. And so I get 6 times -2, that's -12. -12 plus 7. -12, -12 plus 7 is going to give me a -5. Okay, so now we have b. So we can use b and any number or value for x. So I think choosing x equals to 0 is a great one, because then you get 6 times 0 plus 7 is equal to, you're going to get 2. I'll just keep going, plus 2. 0 is x now, and then b is -5. We found that already. Okay. Uh, so those terms drop out, and you're left with 7 plus 5 is going to give me, this is 7 plus 5, adding 5 to both sides, is equal to 2 times a. This right here is 12, and I have 2a there. Okay, so I'm going to divide both sides by 2, which then tells me that a is equal to 6. Okay. All right, so now that we have our coefficients, a and b, that'll allow us then to come back up here and we can write this as the integral. So I'm going to replace a with 6 over x plus 2 dx. And using linearity here, I'm going to have plus, well, b was a negative 5, I should have made that a minus, so -5 over x plus 2. And remember, b had a square, so this is x plus 2 quantity squared dx. Okay, so what that means then is that how we will solve or integrate both of these terms will be different. This is going to be a u sub with a natural log, and this is going to be u sub with a power rule. Okay, so let's go ahead and consider those two down here. So I have the integral of, I'm going to factor out that 6, and I have a dx over x plus 2. Okay, so here I'm going to let u equal x plus 2, then du, of course, is dx. Left with 6, the integral of du over u, which is 6, the natural log absolute value of u. I can pull up the 6 as an exponent, and since that's an even number, then the absolute value won't be necessary anymore, and I can sub back in for x plus 2. This is going to be natural log of x plus 2 to the 6th power. Okay, so that takes care of the first integral. And now let's consider the second integral. So I have minus 5 integral of dx over x plus 2 squared. Okay, now for this one, again, make the same substitution. So let u equal x plus 2 and du. So that's going to be the same for both. The difference is that I'm going to have a plugging in u here. I get u to the negative 2, so bringing that upstairs, I have a u to the negative 2 du. And then this is just a simple power rule, so I can add 1 to the exponent and divide by it. So it's going to be negative 5. Adding 1 to negative 2 is going to give me a negative 1. So I'm dividing by a negative 1, u to the negative 1. Okay. And then I can substitute back in what my u is equal to. So the negatives cancel, and I'm left with 5 over x plus 2, where the exponent on here is a negative 1, but I brought it downstairs, so it's no longer a negative. It's a 1. So you can think of a 1 on the x plus 2 there. Okay. So I'm going to add both of these terms and then add a constant of integration since both of these are indefinite integrals. And so my final answer is the integral of 6x plus 7 over x plus 2 squared dx is going to be equal to the natural log of x plus 2 to the 6 plus 5 over x plus 2 plus a constant. Okay. So while it is a little bit of work, you can see that integrating the two terms once you have the coefficients a and b is much more feasible than trying to figure out how to integrate this otherwise. Okay. All right. I hope that was helpful, and I'll see you in the next video.